Hello, I'm Eric Tedford, R&D Manager for SummitAgro USA, and I'd like to talk to you today briefly about Regev fungicide. Regev is our new hybrid fungicide that contains a well-known triazol fungicide and an organically approved and OMRI-listed natural biological fungicide, tea tree oil. This is the first-of-a-kind product that provides disease control for a broad range of plant diseases on arable crops, fruits, and vegetables. In addition, growers can benefit from excellent disease control from multiple modes of action and with only one residue. I'll explain that more in a second. For the next 10 minutes, I'd like to take you through some of these general properties about Regev so that you'll have a better appreciation for what this product provides and why it does what it does. For starters, Regev has multiple modes of action. What that means is different ways of killing plant pathogens. I'll explain this in greater detail in a moment. The results is that Regev causes cell membrane disruption, inhibits sporulation, spore germination, respiration, and ergosterol biosynthesis. Therefore, there are many ways to both prevent and stop diseases. Another important attribute is that that's highly unusual is that Regev provides control of both fungal and bacterial plant pathogens. Most fungicides have no activity against bacterial pathogens. There also is some evidence in the literature that tea tree oil has antiviral activity, including tobacco mosaic virus. However, more work is needed to determine how extensive plant viral control may or may not be. Tea tree oil comes from the tea tree plant, genus species Melaleuca alternifolia, which is native to Australia. And tea tree oil has been used for medicinal purposes for years, and it can be found in many ointments, skin creams, and lotions today. There are 8 different terpenes in tea tree oil, and that is why tea tree oil imparts multiple modes of action against fungi and bacterial pathogens. To better understand the benefit of this combination of difenoconazole and tea tree oil, let's look at this image that depicts the general life cycle of a fungal pathogen. Fungi generally overwinter in plant tissue, in the soil, or in crop debris. When favorable conditions arise, fungi will sporulate and infect leaves, flowers, and other susceptible parts of the plant, like the fruits. Disease will develop, and the fungus often will sporulate and reinfect other plants in the field or throughout the field. Fungicides are considered preventive if they work early and prevent the infection from occurring. They're considered curative if they stop down infections that have already begun. And a good example of these are the triazoles, like difenoconazole. And very few fungicides have antisporulin activity, but if they do, that would be shutting down infections, more of an eradicant type of treatment, and very few fungicides do that. Difenoconazole provides curative activity. And like other triazoles, that's how it works. It doesn't prevent anything, but it only comes in and stops infections that have already occurred. Tea tree oil, however, because it has multiple constituent terpenes, provides multiple modes of action that provide preventive, stopping infections, as well as curative activity, and as well as antisporulin activity. And I'm going to show you some examples of this in just a minute, all of these components. So what do you mean by multiple modes of action with tea tree oil? Because tea tree oil contains these 8 constituent terpenes, they provide activity on inhibition of sporulation, inhibition of spore germination, disruption of cell membranes, inhibition of respiration, and inhibition of fungal growth. Tea tree oil also inhibits quorum sensing, which is integral to the infection process of many pathogenic bacteria. And recently, there have been publications that have revealed that tea tree oil also induces systemic resistance and systemic acquired resistance in bananas and tomato plants. And we'll get into that in deeper detail in a future podcast. But if you look at the shape, it looks very familiar with one that we see all the time on the roads and streets. It's stopping fungal, bacterial, and potentially viral pathogens. I'm going to take you into each of these attributes. And let's start out with inhibition of sporulation. In this example, you can clearly see that tea tree oil in the top left has completely prevented powdery mildew from sporulating on the leaves here. It might not look all that impressive, but it's important, and let's take a closer look at what's really going on. Using scanning electron microscopy, we can clearly see in the image on the right that tea tree oil is not allowing for normal spore formation. On the untreated plant on the left, you can see chains of spores forming on the surface of the leaf. In another image, showing a normal-looking spore on the left and an unnormal spore on the right where tea tree oil was applied, clearly having an adverse effect on spore development. Now let's take a look at inhibition of spore germination. Using fluorescent microscopy, we can see differences in spore germination and formation of infection vesicles. The blue orbs are conidia or spores. The light green tubes that you see growing from the spores are infection vesicles, and the dark green dots are where the fungus has penetrated into the plant. You can clearly see on the right that tea tree oil has prevented most of the spores from germinating, and there are no infection vesicles there at all. In these images, we can see an elaborate spore structures called conidiophores that have developed in the untreated images on the left. These structures bear conidia or spores that will further spread the disease to other plants. For the tea tree oil images on the right, you can see that there are no conidiophores nor spores. This essentially is what happened in the images of the leaves that I showed you just a few minutes ago. Tea tree oil prevents spore from germinating, prevents infections from occurring, and prevents sporulation and further spread of the fungus. Let's now take a look at the key mode of action that's responsible for fungal and bacterial mortality. That's disruption of cell membranes. These images of fungal hyphae are magnified 50,000 times using scanning electron microscopy, and they illustrate the unique mode of action of tea tree oil on the fungus that caused black sigatoka bananas. You can see in the untreated hyphae treated with mineral oil and hyphae treated with triazol fungicides are not affected. The cell walls of the hyphae treated with tea tree oil break down, releasing the contents of the cell, killing the cell. And it's this mode of action that leads to mortality of both fungal and bacterial plant pathogens. In 2018, the Fungicide Resistance Action Committee, also known as FRAC, recognized tea tree oil as a cell membrane disruptor and designated its own target site, F7, and FRAC Group Code 46, recognizing this as a unique mode of action from all other fungicides. Regev combines two different modes of action, Group 46 with tea tree oil and Group 3 with difenoconazole for preventive and curative disease control. Let's now take a look at inhibition of mycelial growth or fungal growth. And Dr. Moshe Ravini and colleagues measured growth of fungus that causes apple scab on nutrient media that was amended with either Captan and tebuconazole, difenoconazole, Regev, or nothing at all, the untreated check. You can clearly see that all three fungicides inhibited fungal growth, and difenoconazole did an excellent job alone. However, the combination of difenoconazole and tea tree oil and Regev completely shut down fungal growth. So you might be wondering what growth in a Petri dish has to do with the real world. In this graph on the top, you can see the same data that I just showed you, mycelial growth on agar. And in the graph below, you can see data from a field trial where apple trees were sprayed either with difenoconazole alone, Regev, or not sprayed at all. We see the same effect in disease reduction by reducing fungal growth and sporulation in the field. As mentioned already, the spectrum of disease control across both fungal and bacteria is interesting and unusual. However, by looking at the images of a handful of bacterial and fungal diseases, you can also see that these diseases can cause significant losses to crop yield and quality if left uncontrolled. Having the ability to spray one product that controls both fungal and bacterial diseases is also a benefit because you really never know what's going to come into your field, and you don't have to spray multiple times for different pathogens. So that you have a better idea of how devastating bacterial diseases can be, I've included a few images. I think it's fairly clear that bacterial diseases can cause significant yield and quality losses to crops left untreated. On the left, you can see bacterial streak on wheat caused by Xanthomonas species. On the right, you can see tomatoes with bacterial spot, and tomatoes with spot like this are clearly unmarketable. Bacterial diseases can also be devastating, as you can see in this tomato field with southern bacterial blight. And I think it's safe to say that nobody would eat the potato on the right that looks like that, not to mention the smell from bacterial soft rot. Well, we've been talking about tea tree oil for fungal and bacterial disease control, but there have also been some recent publications where they've found that tea tree oil has activity against certain viruses. And this is just a list of some of those publications. There's still a lot that we need to know about the effects of tea tree oil. There has been a publication on tea tree oil having an effect on tobacco mosaic virus. And there's really more that we need to do to find out how extensive or not tea tree oil is on controlling viruses in the field, in addition to fungal and bacterial diseases. Regev is currently registered in many states, but not all at the moment for disease control across the crop list here. So you need to consult the label to make sure it's labeled in the state that you want to use it in. The crops listed in green are in development now and are not on the current label, but will be eventually. The rate range for most labeled crops is from 4 to 8.5 fluid ounces per acre. Pre-harvest intervals are listed on the right. And let's take a quick look at some efficacy data for Regev. I'm going to first show you some data for pecans and control of pecan scab, which is a very important and devastating disease of pecans. In this pecan trial, either Timurex Act at 21 ounces per acre or Regev at 8 ounces per acre or Super Tin Elast alternation program at 12 and 48 ounces respectively were tested. Scab severity was assessed on June 21st, June 28th, July 5th, and July 12th. Regev and the Super Tin Elast treatments provided the best scab control in this trial. Keep in mind that Regev is much more user-friendly than our Super Tin and Elast. In this pecan trial from 2019, nut scab was extremely high. 2 different pecan varieties were tested, Wichita and Desirable, and all treatments reduced nut scab over the untreated check. Regev at 8.5 ounces per acre provided nut scab control equal to Quadristop, Abound, and Inspire. Let's look at some potato data. In this potato trial that was conducted in 2017, Timurex Act was evaluated at 28 and 35 ounces per acre. Regev was tested at 5.5 and 8 ounces per acre, and Enduro was tested at 4.5 ounces per acre for efficacy against brown spot of potato caused by Alternaria alternata. All treatments reduced brown spot over the untreated check, and Timurex Act at 35 ounces was better than Timurex Act at 28 ounces. However, Regev at 5.5 and 8 ounces and Enduro were the best treatments in the trial. This is a good illustration of how the combination of tea tree oil and difenoconazole work together. Compare Regev at the 8 ounce rate versus Timurex Act at 28 ounce rate, and you can see that there's clearly a benefit of the combination of tea tree oil and difenoconazole. In this trial in 2020, Dr. Jeff Miller evaluated these fungicides for control of brown spot on potato. In this trial, Regev at 6 and 8 ounces per acre was equal to the Luna Bravo program, and all 3 were better than the other treatments. In this trial, the 6 ounce rate of Regev was equal to the 8 ounce rate. Let's look at a little bit of tomato data. While these charts look similar, you need to go to the letters of significance, and each bar represents different ratings throughout the season. Inspire Super is difenoconazole mixture with cyprodinol. Regev is difenoconazole mixed with tea tree oil. And while looking at these same 3 rating periods, we see differences between showing up at the last 2 ratings. So at the 8 and the 12 day after application E ratings. Let's look at some cucurbit data. In this trial, Regev was evaluated at 5.5, 6, and 7 ounce rates for efficacy against powdery mildew on squash. The 6 and 7 ounce rates of Regev were equal to Rally at 6 ounces. The 5.5 ounce rate of Regev appeared to be a little bit too low. In this cabbage gray mold trial, Timurex Act, Regev, and Serenade Optimum were tested, and Regev at 6 ounces per acre provided the best gray mold control in this trial. In this cabbage downy mildew trial, Regev at 6 ounces and Timurex Act at 17 ounces were the best treatments in the trial, and numerically, Regev was the best for downy mildew control in this trial. Let's look at grape data. In this grape powdery mildew trial, all of the treatments decreased powdery mildew on the leaves and on the grape clusters. The leaf data is on the left, grape clusters on the right. That's just a quick glance at some of the crops. There are more crops, and there are more data for those other crops as well. I just wanted to share some of the key crop information to show you what Regev is bringing to the program. I hope you found this information useful. Please visit our website at SummitAgro USA.com for more information on Regev or any other of our products. And please always read and follow label directions. I'm Eric Tedford. Thanks for taking the time to listen to this. Have a great harvest.